You manage an Azure environment containing two peered virtual networks, VNet1 and VNet2, and a network virtual appliance called NetVA1. You are required to implement a solution that forces all traffic originating in VNet1 and destined for VNet2 to pass through NetVA1 for security inspection. Which Azure resource should you configure? Option A, a local network gateway. Option B, a route table configured with user-defined routes. Option C, a virtual network service endpoint. Option D, reserved IP addresses. Okay, let's break down this question. We're being asked to configure a solution that forces all traffic originating in VNet1 and destined for VNet2 to pass through NetVA1 for security inspection. Which Azure resource should you configure? The key takeaway here is that we need to implement a forced routing, basically forcing all traffic to flow through a fixed route for security inspection. This is achieved through route tables, which are used to override the default routing table. Within Azure Routes, user-defined routes are configured in a route table and are assigned to a subnet. This allows us to define custom routes for our network traffic. When NetVA1 is configured as a next hop in a route table, all traffic from VNet1, destined for VNet2, is forced to flow through NetVA1. Therefore, the correct answer here is option B, a route table configured with user-defined routes. Let's look at the other options as well. Option A, a local network gateway. While local network gateways are used for VPN connections, they would not be sufficient for forced routing in this case. Option C, a virtual network service endpoint. While virtual network service endpoints allow for secure connections between VNet1 and VNet2, they would not be sufficient for forced routing in this case. Option D, reserved IP addresses. While reserved IP addresses are important, they would not be sufficient. Let's think about how Azure handles traffic routing between peered virtual networks. By default, traffic flows directly between peered VNets without restrictions. However, enterprise security architectures often require traffic between different network segments or VNets to be intercepted and inspected by security appliances, firewalls, or network virtual appliances. Understanding how to override default system routes and direct traffic through specific next-hop targets is a core concept in Azure networking design. In my view, the correct answer is option B, a route table configured with user-defined routes. To inspect traffic between peered virtual networks using a network virtual appliance, you must implement user-defined routes by creating a route table and associating it with the subnets in VNet1. You can define a custom route that specifies the address prefix of VNet2 as the destination and the private IP address of NetVA1 as the virtual appliance next hop. This forces traffic destined for VNet2 to be routed through the NVA for security inspection. Let's look at why the other options are incorrect. A local network gateway is used for site-to-site VPN connectivity to on-premises networks, not for internal VNet routing. Virtual network service endpoints are designed to provide secure and direct private access to Azure services, not for traffic redirection. Reserved IP addresses are simply used to ensure a static IP remains allocated to a resource. For the exam, remember that anytime you need to override default Azure routing behavior and force traffic through an appliance, user-defined routes in a route table are the correct tool.